everybody. I'm Alex Hatcher. I'm with Slalom, and I'm a part of our AWS cloud capability. And today, let's see, it looks like we're a slide ahead. Today, we're going to be talking about our approach to accelerating legacy modernization. Throughout the talk, what we're going to cover our zero legacy campaign. For our clients, we're seeing that modernization is a strategic importance, and it's important to us as well. We'll cover that. We'll also discuss our what we're seeing in the landscape and with our clients today. We'll see some of the challenges that our clients are facing and some of the opportunities that come out of that. We're also really excited about a customer, like our most recent public customer story with La-Z-Boy, where we were able to move them to zero legacy by retiring their Z-Series mainframe. So looking forward to telling you more about that. Zero legacy. So first off, what is legacy exactly? To us, we see legacy, like a legacy system is anything that you have to change that you have to look at, or that is a barrier to modernization. So or innovating in the way that you want to. So I think we've probably all been in that situation, or a lot of us have, where we're like, hey, the product team wants to innovate. We want to see something new. We see an opportunity for our business. But then when it comes to a technical discussion, we start to see, oh, but we've got to touch this, system X. And if we do that, everybody kind of starts to pull back, and we kind of see that idea or that creativity die on the vine right there in that moment. To us, that's really what our zero legacy campaign is about, is solving that problem. We want to move you into a position where you're able to think creatively, be imaginative, and not have the drag of legacy on your, in your space. So let's see. So a key qualifier that we see for a lot of legacy systems, typically they're monolithic, typically they're stateful. Typically what we see in modern architectures is that they are microservice, so non-monolithic, and that they're stateless. So there's a need for us to kind of make a paradigm shift between the two overall. And mainframe specifically is, ZOS, AS400 workloads are very stateful, very monolithic and centralized. So, that's kind of like a key candidate for us, in a part of our strategic initiative in terms of what we want to modernize. What we're hearing from our clients in this space is that their costs are rising, and that it's difficult to hire. I'll give you an example of one of our clients in the gov space. So the original developers of their mainframe they trained their children to actually be able to maintain the system after they're retired. So it's a very real scenario for them where dad is on the beach getting a phone call from his daughter who's saying, hey, I'm in the COBOL code. I see you in the comments. What were you thinking here? When we modified this or when we created that. So that, to me, that says our clients are being extremely creative about how they are trying to solve that skills problem of these legacy technologies. So we see that the problem is there. But so why now? And we see the pressure from the cost and the timing overall. But what's kind of moving us forward? And AI is a big component of that. Probably no surprises for anybody. What we're seeing in the AI space, these mainframes, or AS400 legacy systems, kind of have the being able to access the code, the data, monitoring real-time information is more of a black box than anything that we're going to deal with in a cloud environment where we're heavily monitoring a microservice level. So generative AI has been extremely good at allowing us to reverse engineer those systems in a way that we never have before. So what we used to do in those systems is we would have numerous solution architects that would descend on a large code base, describe that, then synthesize higher understanding of that code base, build diagrams, and then get feedback on that to validate what they're finding, and that's extremely labor intensive. It's extremely costly, but what we're, what Gen AI has opened up for us is what we can do now is we could provision a Kendra index, we could provision a Bedrock knowledge base, and we can essentially zip up our code, load it into an S3 bucket, index it with Kendra, and then access our knowledge base through an MCP and like Q developer or Q CLI, and we're able pretty much within an hour to start asking questions about our code to understand it, that can support a process where we can start documenting it and open that up with a very little overhead. So I think just that in itself, the ability to use generative AI to assist in the re-engineering process is really driving us forward. So we're using generative AI in our modernization in a few different ways. We've already touched on the reverse engineering process and how we're able to really open up these legacy systems and describe them and understand them in a way that we really never have been before. We're still seeing productivity gains from using generative AI just to augment like our traditional SDLC process. So now imagine I'm using my preferred coding agent, which is definitely going to be Q or Q CLI, and now what I'm able to do, not only am I able to just use the default model, which we've all seen is like a great productivity increase, but now we're again able to bring that context of that legacy code into that process where we can still use that to augment our traditional SDLC with tremendous productivity gains, like usually about 30% and sometimes more depending on the problem space. So now let's look at our forward engineering process. So if we're able to, we see that we're able to describe these systems, we're able to extract that knowledge from them. We're also now, we've seen really great advancements with spec-driven development toolkits like Kiro CLI, that announcement that just came out, where there's opportunity now for us to lean into the future, which could be spec-driven development supported by what we're able to extract in our reverse engineering process. So just to try to paint a bit of a picture of that, not only are we able to use generative AI to kind of get those a high level domain explanation of what the system does, but we're also able to decompose those domains, and we're also able to look at and define and see the execution paths of the functions that we need to do or the subroutines that need to be executed to achieve a task from end to end. And if we're thinking about it, it's kind of that's very similar to what we think of as a microservice, a single execution path of a single function. And so with context and with that fully documented as a part of our process, we start to move into territory where it makes sense and it's completely possible to do more of a spec-driven development process that's bringing all of that information into context with, again, full traceability of that specification back to the original code so we can validate as we go. So far, we've talked a lot about technology, and technology is extremely important. But I think the one thing that we really do at Slalom, that we do really well, is that we connect with our clients and we meet them where they're at. So it's not just about, we could go, what we've seen from our clients in some cases is they may say, hey, our mainframe or our AS400 that's an IT, that's owned by IT, and so we kind of own the trajectory of that service. Or maybe a product organization says, hey, I want to do something totally different than what we're doing, and they peel off and go in a completely different direction. We have not really seen that be successful. What's necessary is that we get everybody aligned, because at the end of the day, like, that legacy system is at the core, and it's been there more than likely for a few decades. Business processes have built up around that. Business processes have built up around those business processes, and we can't simply just rip that out without causing massive business disruption, and that's usually where we see a lot of that failure. So in our approach, we want to pull together all of our stakeholders, build alignment across our client organization, and then based on that, we're able to define a strategy that works for everybody, that's focused on the key outcomes that collectively we all want to meet. So this is our lazy boy, our story that we're extremely excited about this. When we started with Lazy Boy and we talked to them originally in a half-day workshop, they mentioned that they had a mainframe, and we said, oh, let's talk more about that. And they were resistant. It was kind of like, hey, we've tried to modernize this. We've tried to work with this a few different times. We've gone through a few different passes. We've got a team that's working on it, and they're kind of slowly chipping away at it. But we said, let's at least have the conversation, and let's talk about what's possible. And as we went through, we kind of realized that there's some real opportunity here for transformation, and bringing our AWS expertise along with the changes of generative AI, which they had not incorporated into their process at that time, opened up some doors and opened up the ability for us to do an AWS-funded assessment to look at what they currently had. We mapped the dependency. First, we got the code. We used Amazon Q just to look at it and fully understand it. We were able to map the dependencies to third-party, any sort of external systems that surrounded that core batch workloads that they were working on. And so we were able to kind of map out the full ecosystem, and then from that, we were able to identify key stakeholders for each one of those parts of the organization, engage them, get them involved. So we got everyone together and said, hey, is this something that we want to do? We can show you a path. Do we want to make this real? And we did it. We moved forward. And so we moved forward into a mobilized phase. We used Q to accelerate our infrastructure deployment. We used Q as well to start building out step functions to replace the JCL for the jobs. We transformed the COBOL into Python, and we deployed those as ECS tasks. We modernized their DB2 environment to a modern Aurora Postgres environment. So we scaled out, so during Mobilize, we used a subset of the workloads just to prove out that process, and then we went to full migrate. We modernized the full set of workloads. So at that point, we were production ready, but we had built a testing process to ensure that we had functional equivalence before we went into a full go-live state with decommissioning. So at that point, we basically set up this process that could compare DB2 and Postgres and the data as those jobs ran in synchronization. And we saw some bugs that we fixed. But I think one of the things that is the most interesting to me about this process is that we found bugs that they never knew existed that required us to rethink some business processes, and that was new for the organization. That's the first time they were like, hey, we're in this new world, we're in this cloud world, where instead of stepping away from the table and saying, this is just something we can't work with, it's like, hey, not only can we change this code, we can change this process here right now, but what else can we change? What other processes can we modernize? And to us, that's the power of Zero Legacy. I really appreciate you. Thank you so much for my talk. I'm with Slalom again. We're at booth 625. Love to have you join me over there to continue the conversation. Thank you so much.